Hello and welcome back to Black Bear Forge. Today I thought we would make a candle holder that is pretty much just done under the hydraulic press. I don't know if there'll be any handwork at the anvil, doubt there'll be any power hammer work. I did need a big saw to cut this big hunk of steel off of the bar. And this piece is 2 1/4 inches square. Get the metric ruler here. So that's about 55 millimeters square roughly. And it is 3 1/4 inches long, or roughly 90 millimeters long. The size isn't real magical, just a big hunk of steel to make this candle holder. This is all squishing under the hydraulic press. So if you like to see things move under the press, this is the project for you. Now this steel is not mild steel. I'd rather have just plain old A36 mild steel, or even a piece of 1018 would be a little bit better to use for this. This is some kind of shafting off a piece of agricultural equipment, but it's the only thing I've got that's this big, and nice big stuff really looks good for what we're going to do. And you're just going to have to watch it if you want to see exactly what this looks like. And if you want to see the 100% finished project close up, you have to watch till the very end of the video. That's the last 10 or 15 seconds of the video is where we show the finished product. Now when I get around to putting the hole for the candle in this, I'm going to use a big punch. It's 3/4 inch round at the base. That's the size candle I frequently use. If you're using bigger or smaller candles, use a punch that is appropriate for that. But too small a punch under the hydraulic press is going to heat up, it's going to get too hot, you're going to have problems with it. So if you're going for smaller candles, you might want to punch them by hand so that the punch is not in contact with the material for as long or at as high a pressure. Now this punch is made out of H13, that's heat resisting steel. It will put up with the abuse as well as anything, but it can't be cooled in water. So that's a place where the Atlantic 33 that we've used for some of these punches might actually be superior, because you could take it out, cool it in water, and go right back to work, maybe even in the same heat. To keep this from getting stuck, I'm going to use 2 things. I'm going to use coal dust. You've seen me do this under the power hammer, and coal dust helps prevent punches from getting stuck in a hole. I think it has some lubrication effect, but a lot of what it is the coal dust is burning, and as it burns, it off gases, and that creates pressure down inside the hole where the punch has everything sealed up, and that helps push the punch back out of the hole. It's not a real dramatic effect, but it keeps it from bonding down there in the hole, and I think the contamination from the coal dust probably also helps keep it from sticking, just like contamination in a forge weld will keep your forge weld from sticking. I don't know if that's a very scientific approach to this, but I know coal dust does work. The other thing that helps is actual punch lube, and this is a commercial product from Quick and Dirty Tool Works, is one I use. I've seen recipes online for it. It's essentially grease or wax with some graphite in it, and it might have some molybdenum in it to cool a punch in if it's not too hot. If it's too hot, all you do is burn it off and smoke it, and it's a waste of a store-bought product. Better to just let the punch air cool and then go back to work once it's cooled off. Anyways, let's go get this really good and hot. I'm going to turn the forge way up, then we're going to go to the hydraulic press with flat dies. First thing we're going to do is squish it and see if we can make it bulge out in the middle. Okay, we've got this good and hot. We'll take it over to the press. First thing I'm going to do is just knock the corners down a little bit. And yes, my press runs fairly slow because I've got a smaller motor and a lower speed pump to keep from using as much power as a bigger press would. We have limited power in the shop here. I'm going to get this hot again. And that'll just help concentrate the force to the center of the mass instead of around the outer edge. I want to just squish it straight down until it's about 2/3 of its original height. So I want to take it down to about 2 inches. That's all it's going to move for now. That's the full 24-ton force at that point. So that's full pressure. Once it quits moving at full pressure, there's no reason to leave it under there. I do see a little bit that's off. That's almost what we want. That just bent my die holder. Shoot. So we'll just squish straight up and down now, and that won't bother us any. Just make sure there's no lateral load on this. Next heat, we'll punch the hole for the candle holder. I put my touch mark on the bottom of that between heats. That way I don't have to mess with it when we're done. Hopefully we won't destroy it. This is when we put coal dust in there. We're just using a flux spoon. You want to put that punch in about as far as you think the candle needs to go in. I think I'll go just a little bit further. See the hot gases coming out of there as the coal burns. And all I want to do here is just clamp that so I get the punch back out. And that is pretty close to done. Yeah, I think that's a deep enough impression. The only other thing I'm going to do is I'm going to bevel that a little bit with a ball punch. I'm just going to do that over here at the anvil. Seems nice and easy. This will just round the edge of that so it's not as abrupt. Then I'm going to take the same punch. Just make sure I didn't create a little burr there. And that should be it as far as the forging goes. I think a nice wire brushing would be in order. This is one that would really benefit from wire brushing hot, but it's hard to hold on to, so this is one I'd rather have help, so I probably won't use a power wire brush hot. I'll wire brush it like this hot. But power wire brushing hot really leaves a nice finish, but I'd rather have this held solidly and two hands on the grinder. And since I don't have a helper in the shop, we aren't going to do that. If you keep doing this till it finishes cooling, you will get quite a nice finish on this. Now I've seen that same sort of a candle holder done under a power hammer, and it's really about the same approach, just a little bit different tool is all, but you can do it either way. To do this by hand, you would need some friends with big sledgehammers, but you probably could do it if you really wanted to. But this really is the type of forging that a press or a power hammer leads you into, because the tool can do so much of that heavy work for you, and you can get these dramatic results without killing yourself all day. Now I talked a little bit about the press during that. My press is a slower press. It runs an 11 gallon per minute pump at half speed so that I can run a 2 horsepower motor. That was more economical to build, and it doesn't require as much power in the shop. Now I could up that to something like a 3600 RPM motor, run it at the full 11 gallons per minute, and it would be twice as fast, but it would require a 5 horsepower motor, bigger circuit to plug it into, more power use, more expensive motor, bigger footprint on the motor, which means it would no longer fit under the press where I have it right now. And that's all stuff that would be possible if you're building your own press. I strongly encourage you to do the research on that. I am not the authority on presses. This is all based on James Batson's book on building hydraulic presses. So just do a search online for James Batson and hydraulic presses if you're wanting to build one. The advantage of the slow press is that you get some reaction time. Things don't happen so fast that you get yourself in too much trouble. You notice that I had that up on edge to push the corner down, and it wasn't perfectly lined up, and that made the die slip, and it had enough power to bend the die holder. It's not a catastrophe. It wasn't really a dangerous situation because it wasn't going to go anywhere, and I can see it, I can react to it long before it becomes a problem. If that press was moving 4 times as fast with 4 times the pressure, something like a 100-ton press and some people have out there, that might be a problem. You might not have the reaction time you need, and that might become a dangerous situation. So that's something to think about, and that's another reason I like the slower press. I just think it's safer. I think I'm less likely to screw things up, even though it does take a few more heats and a little bit more time to get something done under it. But I'm not a great big press user. If I was, I would probably be looking at buying something like the Yang press or the Big Blue press, something like that. But after buying a new power hammer last year, I doubt that I'm buying a brand new commercially made press this year. So this one's just going to have to do it in my shop. I'm going to have to redesign or at least repair that die holder and get it put back in shape. I tried to bend it back, but there's no way I can bend that by hand or even with a short pry bar. It's going to have to come out of there, get cut off and re-welded. So those are just a few observations on the press and hopefully answers the question some of you have already been typing down there in the comments. Because most of you comment without actually watching the video to see if I answer your questions. Anyways, that is still way too hot for me to show right now. It's sitting over in the anvil cooling. I'm going to put a little bit of wax on that before I'm done. I'm going to go into the house this evening, find a candle for it, and get a nice little shot at the very end of the video so you can see exactly what it looks like finished. I hope you enjoyed watching that project. If you did, give the video a thumbs up. If you haven't done so already, I would love it if you hit that subscribe button. If you ring that little bell down there, you'll get notifications when I post new videos. Then feel free to stick around, watch a few of the other videos, share the videos with your friends or on social media. But remember, make time in your day to get out to your shop, make something, but stay safe, wear your safety glasses. We'll see you for the next one. If you would like to provide financial support for the videos at Black Bear Forge, there are links in the video description for both PayPal and Patreon. These are merely donations. The content is free and will remain free. Thank you. Molybdenum. And I think it might have some molybdenum. Yeah. And it might have some molybdenum. And it might have some molybdenum in it. I hope I got that right.